Hello and welcome to part 2 of Tevora's webinar series on cloud security, using automation to enforce compliance in the cloud. My name is Matt Fullerton, and I'm an account manager here with Tevora. But today we're going to be hearing from Chris Callis, our Director of Cloud Security. If there are any questions, please use the function for questions in GoToMeeting, and we will address those at the end of the presentation. But first, just a little background. Here at Tevora, we're a management consultancy focused entirely on information security, compliance, and enterprise risk management. We offer just a huge range of services from security assessments and penetration tests to solution selection and implementation. Also, if there are any compliance frameworks that you'd like to align with, like ISO 27001, SOC 1 through 3, PCI, HIPAA, HITRUST, we can certainly help with that. We've been doing this for over 16 years, and we have experience with pretty much every environment out there, like AWS, the Google Cloud, Azure, and more. So that's a bit of information on who we are here at Tevora. Chris, why don't you take it away from here?
Perfect. Thanks, Matt. So my name is Christopher Callis. I'm the Director of Cloud Security over here at Tevora. And today is part 2 of our 3-part series of leveraging automation to enforce compliance within the cloud. So during the first webinar, what we did was we took a look at the foundation. We were working out of a single VPC, a single network. And what we were doing is we dove into tools such as AWS Config and AWS Inspector, which allowed us to monitor the environment and the resources such as our virtual machines for compliance within the cloud. Today, what we're going to do is we are going to build on top of that. We're going to add to our environment, make it slightly more complicated. We're going to be working out of a public and private subnet. We're going to have machines in both. We're going to start locking down the security groups and get a baseline understanding of what's going on in the environment. After that, what we're going to do is we're going to re-explore tools such as AWS Inspector and Config and start to plan out ways that we could implement automation within the cloud. What you will see during this review is, it's not just necessarily a simple click and automation is in place. It's really understanding how the resources and services actually work for your particular workload, and then building out automation around that. So we'll dive into that in just a bit. Again, my name is Christopher Callis. This is part 2 of our 3-part webinar series. This one is entitled Using Automation to Enforce Compliance. To take a look at some of our previous webinars, here is our website. You can take a look there and you'll find stuff such as our PowerPoint presentations and videos from the webinars themselves. Some of the stuff we want to be able to cover is helping you to make informed decisions when it comes to architecting security and compliance within the cloud. We're going to explore proven strategies and techniques to ensure that your organization's security intent is reflected in your workload security posture. We're going to dive in, like we were saying, about technologies that will allow you to measure and enforce compliance requirements. And then what we're going to do is, in this webinar, is build upon what we learned. We're going to introduce automation. We're going to explore its limits from the basic services, and then we're going to plan out ways to actually build out that automation. My name is Christopher Callis. Before we started the cloud security practice, I was responsible for the PCI, PADSS, and point-to-point encryption practice over here at Tevora. Over the last couple of years, we've had multiple clients that wanted to start migrating their workloads from, a typical data center and migrate them over to the cloud themselves. And they wanted to ensure that their workloads were going to be PCI compliant. That's where I came in. So over the last couple of years, we've helped our clients develop these workloads, build out their programs, and now we focus on cloud security as well. Just like Matt was talking about right here, here's just an overview of some of the consulting practices and security services that we offer here at Tevora, from compliance to solutions. You can see we cover the whole gambit, but we are solely focused on information security. We have a wide variety of clients spanning multiple verticals, anywhere from brick and mortar stores to FIs to research locations to aerospace. So retouching on some of the interesting findings that we had during the last session, which this series is designed to remediate. One of the first things that we found is compliance is a very manual process. A lot of organizations are migrating over to the cloud in hopes that they're going to gain efficiencies within the cloud and really help streamline their operations. What they're finding is it more kind of looks like this, where you have the auditor, and then you have maybe this DevOps cloud type centric thing. And what's happening here is, we run across some interesting predicaments. People have built out these environments to really keep humans away from data and away from production. But then an auditor comes in and essentially they're asking to make the environment temporarily less secure so they could gather their sample sets within the environment themselves. So this whole entire concept of DevSecOps was to keep people away from data and production. So this real manual process just feels wrong. So that's what we're here to really explore and see how we could remediate these things. Again, compliance is very manual. The other thing that we're finding is, organizations are running into a lot of audit fatigue. Not only are they performing audits in environments that they may not necessarily be familiar with, but then, you have multiple environments, you have multiple compliance requirements that happen all throughout the year with little differences. So hopefully, once we're building out these programs, we're designing these automations and compliance programs with that in mind to help you be able to really stay ahead of the ball and ensure that you could demonstrate that you've been maintaining compliance throughout either just at a single point of time or during the entire assessment period. That way you're not utterly exhausted. So today what we're going to be covering, again, is Cloud Trails. This is the recorded API activity that passes through your AWS control plane. These are similar to critical infrastructure logs. They record user actions and anything that really happens via API. Next, we're going to dive into AWS Config. This is a fully managed service that provides you with AWS resource inventory, configuration history, and really helps you demonstrate compliance over time. We're going to be taking a look at Inspector. This is a security assessment tool that helps you improve the security and compliance of applications deployed in AWS. You do things like perform vulnerability scans, do hardening checks, and so on. Then we're going to be building on top of that, and we're going to be exploring a little bit of SNS, or Simple Notification System. These are message queues within AWS, and we'll be seeing how those actually work. We'll be taking a look at Lambda functions and creating a couple of those to complement config and inspector results. And we'll be using CloudWatch to set triggers, which will be coming from SNS to kick off Lambda functions. So like we were talking about, when we first started this webinar, we started off with a single VPC with a public subnet. In this webinar, we've grown that quite a bit. And what we've done is we have created a public and private subnet. And then we've locked down the private subnet security groups themselves to prevent the type of routing that you would want from maybe like a cardholder data environment. So we're going to explore how that was actually configured and kind of go from there. So let's start. So we really wanted to start moving towards leveraging infrastructure as code. Infrastructure as code is great because it gives you a consistent way and process to deploy applications within AWS themselves. This really, kind of goes back to the intent of us wanting to keep people away from data and away from production. That way you have a consistent environment that's gone through its change control and approvals over time. That way, if there is something that needs to be changed, like what we'll see here in some of the examples, that'll go through its change control process, that'll get updated in GitHub, and then what will happen is AWS will pull that change once it's actually been pushed and apply it to the environment itself. So what we have here is we have a CloudFormation template. And what this CloudFormation template does for us is it deploys a VPC, sets up public and private subnets in a single availability zone, and sets up some baseline security groups. In previous webinars, what we did was create these things manually. So if you wanted to take a look at how that was done, please take a look at the webinar link that we provided, and we'll kind of go from there. And what we're going to do is we're going to continue on this journey, creating an event-driven information security program. So let's take a look at what was just created. From here, you can see that the webinar VPC was created. You can see the CIDR range is 10.00/16. Next, we can see the public and private subnets that were created from the CloudFormation script. And let's dive in to confirm that they are public and private. So on the public subnet here, we took a look at the route table, and we can see that it's attached to an internet gateway. That means it does have a route to the internet itself. That's a quick sanity check that you can do to make sure that your environment is segmented or not routable, to the actual internet itself. Let's take a look at the route table. And what's useful within the route table itself is, one, we could see the VPC that it's associated with, but we could also take a look at things like the subnet associations and the routes that exist. So again, we could see the route is tied to an internet gateway, which means that it is publicly accessible. And subnet associations. I like to check here just to ensure that there are no additional subnets that are associated with the actual route table itself. That way we have strict control over what can and cannot talk to the actual internet. Now let's take a look how the private subnet actually differs. We can see that it's associated with a private route table, and that is also associated with the same VPC. Diving into that route table again, we see it's associated with the VPC, and we'll take a look at the routes and the subnet associations and see how that looks different. So instead of the quad 0 routes actually being tied to an internet gateway, it's now natted, which means there's not going to be a route to the internet for anything that exists within this route table. We could also see that it is tied to the private subnet that was created. And we could also see there that it has a different CIDR range, which was established during the CloudFormation process. Let's explore some of the other things that were done during the CloudFormation process. This is another quick sanity check that you can do. So on the subnets, you can see auto-assign public IPv4 addresses. On the public subnet, that is set to yes, and the private subnet is set to no. So public addresses will not get assigned to resources that live within the private subnet itself. Now what we're looking at here is the 3 EC2 instances that exist within our environment. We have a reverse proxy, a web server which lives in the DMZ, and a private database. Let's take a look at the inbound rules. We could see here for the reverse proxy that 22 is allowed in from a whitelisted IP address, and it also allows 443 over quad zeros, allowing the web access itself. We could also see that it's associated with the public subnet that we just reviewed. For the private web server, We're going to take a look here at the inbound rules. We're going to also see that it has a private IP address, and that's the internal IP address. Notice that it doesn't have a public IP. And right now, it's not associated with any rules. We're going to go ahead and change that here in just a little bit, and then confirm segmentation within the environment. Now let's take a look at the private DB. Again, you can see the private IP addresses is assigned. It also correlates to our private subnet, and there is no public IP address. Again, there are no security groups. Just as a reminder, the EC2 security groups or VPC security groups, those are stateful rules where the VPC ACLs are stateless rules. So when traffic hits your environment, it's going to hit the VPC ACL first, and then it's going to hit the EC2 security group. And that's kind of how the restriction for traffic actually occurs. So we're going to filter not too many security groups. We're not going to do that right now. So we're going to create our first security group here. And essentially what we want to do is allow access to the web server. Currently, we're just operating out of a public and private subnet. So that's where our SSH bash chain host is actually going to be. Which generally what we want to do is have a separate DMZ that's whitelisted and kind of go from there. So what we've done is give it a brief description. We've associated with our VPC that we created with the CloudFormation script. We can see it right here. We can see that there currently is no inbound rules. So let's add a couple. Since it's our reverse proxy, we're going to allow HTTPS in from anywhere. Oh, excuse me. Since this is the web server, we're going to allow HTTPS in from the reverse proxy itself. Again, we're going to allow SSH in, but instead of SSH being publicly accessible, you're going to have to hit the bastion host first to connect to this box. And since there is a database, we're going to allow database communication to pass through the proxy server here from the reverse proxy. And then to test segmentation, we're going to enable ICMP. From the actual reverse proxy itself. All right, so now that we have the web server security group done, let's go create another one. We can see in the bottom, the inbound rules are now populated. Just a quick note, since these security groups, it's stateful inspection. So what that means is once it's actually established, there's not really a good way to handle egress from the actual EC2 security group itself. That's where you'd want to actually leverage a VPC ACL to restrict outbound communication. So next, we're going to create the database server security group. This one's going to be a little more tightened down, as we'll see here. And again, it's associated with the VPC that was created via Terraform. And now let's edit some of the rules. First thing we're going to do is allow the MySQL connection, but instead of having it come from the reverse proxy this time, we're only going to allow the connection to the database server from the DMZ, or where the web server actually lives, on the private subnet. Next, we're only going to allow SSH access from the private subnet. So that means we're going to have to hit the bastion host first. Then we're going to have to hit the web server, and then we'll be able to access the database server itself. Now what we're going to do is we're going to attach the security groups that we just made to the actual EC2s. In our next session, we're going to show how this can be done during essentially, as code when we deploy. But just like the rest of our webinars, we want to get the foundation in first, and then we'll leverage in the automation and moving towards infrastructure as code. We can see the security groups that were just created applied to that private database security group itself. Instead of being empty, we can actually see the rules populating. Next, we're going to attach the security group to the private web server. So we're going to move it from no ingress to web server itself. Now we can see the new rules populated. ICMP is kind of funky because depending on how you have it configured, and I'll change the configuration here in just a second, just because I think I have it set to echo reply. You'll see it go from TCP port 0 to 1, or you'll see it from -1 to -1. I've run into that a couple times during an assessment, but never really got a good explanation on what it was. But digging into a little bit and kind of setting up these labs for you guys, it just essentially means it's ICMP. So now let's test the segmentation. So we've SSH'd into the reverse proxy. So we're attempting to hit the database server here. And we're seeing that we're getting 100% packet loss. Now let's try to hit the web server. And we can see that they're getting a response. So even though they're in the same subnet, the security groups are restricting what can and cannot be done. So now what we're going to do is try to SSH in to the actual database server itself. And we're seeing again, it's going to time out. Now we hit the web server from the reverse proxy. And when we fast forward a little bit, we can see that there's 100% packet loss just because I have echo reply turned on in the actual security groups. So that'll get changed here. And then we'd be able to communicate. Next, what we're going to do is we're going to dive into role creation before we get into config and inspector. So AWS, you'll see here that you have AWS service, and it'll be tied to the various services that are used. So there'll be a core inspector role, there'll be a core config role. Some of these items are configured automatically for you when you start actually using the service, but least privilege is really the practice that AWS kind of demonstrates here. So in order to open it up or introduce some automation to the features, we do have to start creating a couple additional roles and policies, which we're going to do here. And we're going to build these out, some for this session and some for future sessions. So right here, what we're doing is we're creating a cloud formation read-only access. So in the next webinar, what we're going to use that for is drift detection. So what we're going to have is we're going to have our infrastructure as code that's gone through our change approval process. And then drift detection is going to be applied. So if the environment starts drifting away from the approved template, we could either take the route of automatic remediating and rolling back the actual changes that occurred, or what we can do is set up alerts, have it sent to our ticketing systems, and hit a change control process from there. And depending on how you want to set things up, right now we're just focused on services themselves. In future webinars, what we'll do is start creating a centralized security role. So that's where we're going to start using another AWS account and having cross-account privileges get introduced. You could see for service linked account roles, sometimes these are automatically created, and just wanted to show you guys that you cannot duplicate them. It gives you the notification asking you to change the name because it already exists, but it's not going to allow you to create multiple of the same role for the service. Otherwise, when the service calls it, it's not going to really know what to do or what to select. So it's really just one and done. Next role we're going to create is with EC2. This is going to be tied to System Manager and Inspector. And what this is going to allow us to do is leverage automation in terms of, hey, if there's inspector results, what type of actions do we want to take on top of that? It'll also allow us to easily deploy the SSM service to our virtual machines versus having to SSH and install them manually with curl. And we'll show what that looks like here in just a little bit. And right now we're not assigning tags. These tags definitely help out a lot when it comes to the actual remediation, as we'll see here in just a second. So I have applied tags to the actual AC2 instances, which will allow us to determine if units in production or not, amongst other things. So it helps us define the actual scope itself. Config has a couple different options. It allows you to do customizable operations or config. Each of these have predefined policies. Note when you're actually creating these that they don't allow you to add or remove to the actual policy themselves. And that's for service link roles. Again, service link roles don't allow for tagging either. And it's important to really dive into these rules and understand them, just because without a thorough understanding, it can give you a pretty big headache when you're actually configuring and wanting to do certain things with automation. So it's good to have these foundational items actually in place. And right here, we're just expanding on the role that we created a little bit earlier. That way the agents are deploying. As I was going through and setting this up, I was having issues with some of the agents reporting back unhealthy. So wanted to go through and modify that just a little bit. Another thing I noticed too is even though I removed the previous role and re-added it with the same role name, I was still having issues deploying the agent. So what we'll see is in a little bit actually probably recommend deleting the role and then creating the same role with a different name. And that seemed to help with things like inspector, which we'll dive here after we cover config. Next, we're going to define a trust policy. And what we're going to do with the trust policy here is we're going to modify them slightly to allow our various services to actually assume roles. As you're creating these policies, you could fine tune, what you want them to access based on ARN. Right here, I'm just doing any because we're operating off of a single account. Again, I enjoy taking a look at the JSON or YAML output just to make sure that it's doing what we've specified for it to do. And we could see what it's entitled to from a config perspective and the resources that it's restricted to. And what we're going to do is we're going to attach that trust policy to an actual role itself. And just confirming that everything looks good here. Going to make a slight change to the effect on the policy. We're going to adjust the principal, and we're also going to tell it to allow STS assume rule, which will allow the service to leverage its policy that it's attached to. And it's allowing the service config, AWS config, to actually be the principal. We're going to add one more action to allow it to assume the role. Dealing with error codes is always fun, but part of the process. And it was just a comma. And you'll see here as you're going through the policy editor that if something else kind of overwrites it, it'll prevent you from actually introducing mistakes within the environment, which is good. So we're going to pull that out. And then when we attach this to a config role, we're going to define the principal in another location here. We'll cover that in just a second. So when we during the last webinar, one of the tools we covered was AWS config. We had a couple of rules in there to prevent restricted SSH access, to ensure that CloudTrails were enabled. And we've added a couple more here. And we're going to use AWS config. We're going to use the trust policy that we just created. We're going to use Lambda and SNS to build out some remediation capabilities. So the trust policy has been defined. Right here, I'm just going to enable the Lambda service as well, because they're all going to play into each other here in just a moment. We can see Lambda has the access that it needs. Next, what we're going to do is we're going to establish a CloudWatch event. The CloudWatch event itself is going to be looking for notifications that come from SNS. And those SNS notifications are triggered from changes and correlate back to AWS config rules that we created. So we're going to create a customized rule here. And you may see a little troubleshooting. So I'll fast forward if we get into that. So we have a customized event pattern here that prevents S3 bucket public read and S3 bucket public write. And if this does receive it from CloudTrails, or if these filters actually hit, or parameters hit from CloudTrails, what it's going to do is it's going to send an SNS notification, and that SNS notification is going to be picked up by Lambda. So next, we're going to add the target. Notice at the top it says Lambda function. We're going to flip that to SNS here, because I didn't see the SNS queue that we created, or SNS topic. So we're going to do the config topic. That's a topic that's created from AWS config. We covered that during the last webinar itself. We're going to give it a name. And the reason we're going through doing this is because when we were leveraging before AWS config, looking for publicly readable S3 buckets, they have some AWS managed templates, but either some of them work in terms of an alerting perspective, but the automation wasn't quite clear. So this is where it's important to have an understanding about the services, how they communicate between the environments. And there's not one right way to approach this, as you'll see from here, and as you'll see from the future webinar as well. But there's always multiple ways to approach it based on what your organizational requirements are and stuff like that. So for example, instead of setting an SNS notification to an email or to Lambda itself, you can do things like, hey, let's have it into a change ticket, and that'll open up a change ticket for you. You could have it go to things like Slack, and then you could introduce automation there to implement some type of human interaction to either authorize or prevent the change itself. Just adding a brief description. They always help. And now we're inside Lambda. The webinar Lambda function we'll get into in the next webinar here. That's a pretty neat one that we put together. But we're going to create a new function here that will automatically close out the publicly S3 bucket once it's detected. Some of the Python code for this is available from AWS, and we'll include it in the footnotes of our PowerPoint presentation for you guys to download if you wanted to implement something similar within your environment. Giving it a brief name, and then changing the runtime here to Python. And you can either choose an execution role here or on the next page. It doesn't hurt either way, just depends on what you like to do. But in the end, we're all going to move away from manually configuring this and then doing it all through something like Terraform or CloudFormation. And Lambda is pretty neat itself. It allows you to tie in a bunch of different processes. I was just checking the role there, and really customize the type of remediation activity that you want to perform. So it lets you get really granular, which is why Lambda is so used. What's great is, the more exposure that you actually get to Lambda, you could still use tools like config and services. But as your, security team or your development teams get used to it, it really starts applying that automation that allows, organizations to move people away from the actual data and from their production environments. And as we saw there, I didn't see that the Lambda role had the config trust policy that I wanted. So I just attached that policy that we created just a couple of minutes ago. And this is really start building out the function here. So we could see that we have a high-level function called AWS config S3 open access responder. I didn't have a naming convention down, and at the time, that seemed like the best name for me to choose, which I'm sure I'll regret in the future. But then you want to add a trigger. So remember, before we created a CloudWatch event. So what we're going to do is the trigger is going to be that CloudWatch event. And that rule is created from the CloudWatch event. So the first thing we're going to do is we're going to select the rule from the dropdown. So that's going to be the trigger. And that trigger, just as a reminder, was, hey, do we detect an S3 bucket that's publicly readable or writable? Again, that's the same policy that we saw before. And now the trigger's been established. You could add multiple triggers. However, since that's going to be really the only thing that's going to be kicking off this process, we want it kicked off before. So within AWS, we learned how, cloud trails happens near real time, or there's a slight delay. So that means is depending on the service that you're leveraging, you either have a 15-minute delay or a 5-minute delay. We want these things to respond as quick as possible. So with stuff like the S3 buckets and stuff like a couple of the other functions that we're going to be seeing, like modifying EC2 security groups, we want those to happen reasonably quick, which limits the exposure. And right here, this is the Python script that's available from AWS. Again, we'll put that into the Cliff Notes of our actual discussion. Right now, the environmental variable, we're going to set it to the topic ARN, which was the SNS topic that we created in the beginning of this process. We've already established the role. We can see that we selected the Lambda role itself, which is fine. And now we're going to save and make it go live. Again, from AWS config itself, we see that it detected 2 publicly readable buckets. And those publicly readable buckets are going to send off a CloudTrail alert, which is going to get picked up from CloudWatch. And then CloudWatch is going to send that alert to SNS, which is going to get picked up by Lambda. And there could be multiple subscriptions to SNS. You can have it email you. You can have it, again, tie into like your Jira ticketing system. You could have it do things like push into Slack and invoke some type of human interaction or some type of trail that's a little more traceable than saying you're searching through your email, when an assessor comes asking, hey, what are all the different security events that you've responded to? Because you still have the responsibility to show that you're demonstrating compliance throughout the year itself. Digging through an email is sometimes difficult and then, may violate those log retention policies. So, it's really good having all this information go into a SIM. That way you could do further investigation if needed, but also, building it into your ticket and your change control processes or through Slack, depending on how you want to demonstrate it. Always, multiple ways to approach this. That's the trust relationship we were talking about earlier, which allows Lambda to execute or, assume the actual role. So when we were doing the trust policy earlier, that's one of the things that we were pulled out when we got the little error. So we just applied it there. And we're going to fast forward here a little bit because I think there's a little bit of troubleshooting that's going on my end, just to see what's kicking off. So after this function is done and created, before it kicked off, so this is where that lag time kicks in. I got a little impatient. I'm like, hey, the objects, it was showing that I had 2 publicly accessible buckets. I was a little impatient, and in the background, it automatically closed them out for me, which was great. And that'll be confirmed by email notification or whatever you choose your SNS to push the actual topic to. Next, what we're going to do is each of our EC2s, and this could be done as you're actually provisioning them. I did it after the fact so we could show you what's going on here. This allows us to work with Inspector. So instead of going in and manually provisioning the systems, this allows you to do multiple things. SSM allows you to do multiple things. You could have a patch baseline. You can have it built into things like Inspector. It really allows you to do what you want. Some organizations, they've removed SSH altogether, and they only allow access through SSM. Which is also another approach that you can take. This is where I learned about the glitch. So, I created a role, deleted the role just to demonstrate it as we're building out the session. But we see, you'll see after this that if it has the same name, it takes a little bit of time to actually refresh. And I was getting connection lost ping status. So some of the stuff is a little inconsistent, which is interesting because when we actually went into the manager here. So there's a couple different ways you could push these things out. I was going to do it as a shell script. We could see that it's a session lost, but there's another script there that allows you to update SSM, and it just pushes out for you automatically, which is really the route to go. Plus, most of these EC2 instances already have it installed. If you're using the standard AWS AMI. But we can see here that they now have all the role, SSM role 2, tied to them. And with Inspector, we're going to go about the same route that we did before. So we're going to have Inspector kick off a result that's going to get picked up by CloudTrail. That's going to get filtered through an SNS topic, and then it's going to tie into Lambda. So we're leveraging the same tools, but what we're going to do here with Inspector is I have two jobs that are set up with an Inspector. The first one is to run the CIS benchmark or just common security hardening practices. And in the future, what that's going to look like most likely is, hey, we have our organizational defined baseline. If this deviates from it at all, somebody says changes their SSH or our PAM deconfig, automatically roll it back. We only want this one master gold image, or what used to be considered a gold image, actually running into production. Not only that, we want to demonstrate to our assessors that are coming by to do PCI or SOC 2 that this has been a state throughout the entire year, not just when they're here. So it really lets you demonstrate compliance. What this will also allow you to do is it allows you to kind of fish out any type of like security holes or misconfigurations that happen in the environment. If you're going towards the methodology of removing people from data, there really shouldn't be people that are getting access to this. So you may discover things like, hey, we have other administrative routes that may not be clearly documented. That happens a lot. So it allows you to really fine tune and consistently improve your security posture using, security events that are coming through. So we created the new SSS queue for Inspector itself. We're going to call it Inspector Patch. And you may see an error message pop up here. Essentially what happens with the error message is with the access policy, I believe it is. I attempted to delete the role from Inspector, but since it was tied to actual virtual machines themselves, it wouldn't let me delete the role, which is preventing some of these things from kicking off. So we're going to forward through here to the next session here. There's the access policy allowing it to actually assume the role. We'll get that all established. Next, we're going to go into AWS Lambda again. This one we're going to do from a blueprint, and we're just going to use the Hello World Python blueprint. And then again, we're going to leverage some AWS resources. And what we're going to build out here is AWS Inspector is essentially doing a vulnerability scan. That's been one of the things that our clients have told us, like, hey, how do I do this in the cloud? I don't want to set up a Nessus agent. I can't stand X, Y, and Z vulnerability scanner. How do I do this in the cloud? So Inspector allows you to scan your virtual machines for vulnerabilities. The big thing with the cloud is understanding roles and responsibilities. Technically, AWS is responsible for the actual infrastructure, right? Not necessarily your security groups or your ingress and egress rules, but that's something a vulnerability scanner can't really do anyways. You know, you would be more worried about, hey, is my Cisco router patched? That would be an AWS responsibility, and you could confirm that in their roles and responsibilities matrices that exist. For if you go to like your AWS console and click on scroll down to the compliance tab, you can download various SOC 2 and PCI reports. What we're building out here is I don't want to just do a vulnerability scan and show you my vulnerabilities over time. What I want to do is if this hits a certain criticality threshold, that it can be resolved by doing like a yum update or an apt-get update, I want it to do that automatically without my intervention because I don't want any critical vulnerabilities running within the environment. If it breaks something, it can always roll back. This is where you're going to really get to play around with your change control processes a little bit, and you need to balance your automation. Because if you're in an environment where you're pet versus cattle type thing and you're patching these systems, this works. Other organizations, instead of actually patching, what they'll do is they'll restack their systems on a weekly, every 2 week basis. So the EC2s no longer exist, and it's just all done as code. But with these, say these are legacy systems or, they're part of our legacy process and we're manually patching them and growing them over time. And we haven't really truly moved over to an infrastructure as code type point of view to maintain our applications and our environments. So this is a way that you could introduce automation to that as organizations are migrating, or if this is just how they approach things. So again, it's another inspector task. And it's assigned to be kicked off via SNS. And we selected the queue that we just created. And this is another AWS script that we'll provide in our PowerPoint presentation that you can do to download essentially a zip file. And what it does is essentially establishes, hey, if we've passed a certain criticality or a CDS threshold, and there's an update that's available for it, it's going to tell the systems to auto update. Perfect. So when you're running AWS Inspector, it takes a little bit of time for those rules to kick off and actually evaluate. It depends how thorough and how large your environment is. It gives you the option to do either, let me exit out of this video here. It gives you the option to do like 1, 6, 12-hour intervals. And if you're loading on a bunch of assessment targets on there, you may not necessarily complete the entire scan. So that's something to keep in mind as you're going through these. So if you're running scans and you're noticing only certain systems and stuff like that are popping up, you may need to adjust the actual threshold itself. There's also a cost explorer that exists. So you can see that every time you kick off an assessment, how much is it going to cost? I think the last time I read the site, if you had something like 1,000 virtual machines and you ran it like every single week, it would cost you $100 a month or something like that. But those prices are always changing, not exactly my expertise, but you can also, those cost explorators are very accessible and you'll see those links everywhere. And to me, that's usually an indicator of like, hey, just want to make sure I understand how much this costs before I kick it off. Let's see here. So today, we built on what we learned about CloudTrails and AWS config. And inspector. Let's see here. And we really started to dive into other services to understand what processes we're running and how things communicate within AWS to really move us towards this infrastructure as code. So let me give you a little sneak peek of what that looks like. And this is something that we're going to be diving into in our future webinars. So right here, I put together a little script or modified a script. And essentially what it does, and we'll get into this more, so I'm not going to spend too much time. But when you deploy it, it asks you what VPC and subnets you want it applied to, and it creates those security groups that we saw in the beginning. So this is an organization-defined public service security group that allows 443 and SSH access. Here's a private security group as well. So when we're doing CloudFormation to push these out, it's going to automatically provision it. Then what we've done is we've created a Lambda rule to evaluate the actual security groups themselves, and then establish the function. And essentially what the function says is, hey, if this thing, if what we find in security group ID 1 and security group ID 2 deviates from these organizational defined processes, automatically roll them back, please. And that's essentially what it does. And so what we've done here, and what I wanted to show you as we're wrapping up, is this is the result of the CloudFormation kicking off. So what we can see here is we can see the security groups are created. We can see that the SNS topics were created. So instead of manually going through and configuring each one, this is all done as code. It also goes and creates that Lambda function that we saw in the very beginning that I said, hey, we're going to touch on that later. We'll dive more into this during the next webinar, but this is the direction that we're going. So we've learned security controls that help you with compliance and enforce compliance. We've learned how to do automation on top of it. And now what we want to do is make it a consistent process across the entire environment. So you could imagine that that code lives in something like your GitHub. It's approved by the appropriate managers, and everything needs to stay the same. So if you have a developer that goes in to change the EC2 security group because they need to get the next application up, it'll automatically roll it back for you. And that kind of forces them down the path of, hey, I needed to open up a change control ticket to actually have this approved and kind of go down that route. So it gives the security and compliance teams a little more oversight into the environment. And that's just really one way to attack that problem. Depending on, what your organization's, how comfortable you guys are with automation and stuff like that, there's a bunch of different ways where you can do it. You can do things like, hey, instead of automatically remediating it, put in boundary permissions and just take those away automatically. And that's also something else that we're going to be exploring. So what I did here is I added POP3 into one of those defined security groups. And what's nice is this is more what we call near real time. So I just created it. And right here, we could see the Lambda's kicking off. It's part of the web security group there, and it's already kicking off the process to revoke the security group ingress rules. So since it's deviated from that initial script that I showed you guys, it's right away starting to pull it out. And it takes about 5 minutes versus 15 minutes. We're not going to go through the whole thing here. What we could see here, a couple minutes later, we can see the POP3 still exists. And I think it was about 5 minutes or so, we can see the POP3 gets just automatically dropped and we get a notification around it, which is really neat. I love that. So what we've done, again, is built upon our pre-existing knowledge and added some security and compliance tools under our belts. We've learned the limitations of some of the default AWS rules from those great compliance tools, such as config and inspector. And we started to dive and tie in other services to aid in our remediation efforts, moving us towards, infrastructure as code. So I hope that was as fun for you as it was for me. And I'm looking forward to our next webinar. So what I'll do here is take a couple of questions. It looks like there is a couple that are queued up right here. So the first question I have is that they have S3 buckets that they need to share with an external partner. And what are all the rules, configs, and security controls that they need to be in place for PCI? So there's a couple different routes that you could go down with this. For the S3 bucket access itself. One thing I would do is I wouldn't just have the S3 bucket publicly accessible for anybody to choose. If you have the ability to lock down that S3 bucket from a source, that's probably the best way, or add some type of authentication credentials for it. Depending on how your AWS environment, if it's like federated interactive directory, it's probably most likely not going to be the case that you would give them an account with access to that S3 bucket. And I tend to stay away from giving them permanent credentials. Instead, it really depends on how often that partner needs to access that S3 bucket. You could tie in an access request process where you could use something like, I think it's called AWS Certificate Manager. And what that does is it allows you to grant them permissions on a timed basis. So, this will issue a certificate that times out after like 60 minutes or 80 minutes or whatever it is. That could be tied to a role or a policy that allows you to access the actual S3 bucket. The other thing that you can invoke within the policy itself is certain types of encrypted channels. So for example, with PCI, if anything's going over the public internet, say they're sending you credit card information, it needs to be enforced and transmitted via TLS or a secure communication channel. So what you can do in the policy as well is you could do things like setting, hey, this needs to come over an TLS over an SSH connection, and not even, the bucket won't even accept it at that point if it comes over an insecure channel. So that's another way that you can, do compliance. Perfect. Awesome. Let's see here. Looks like got a couple of other questions. So the first one's kind of like what I was alluding to a little bit during the talk. It talks, the question is, which route do I go, or what's the best route to implement automation? And it's not necessarily the best route to implement automation. Some people will be like, oh, we do Lambda, and that's like the end of it. Really, the way that I like to go with it is, one, keep in the back of my mind, can I implement this as infrastructure as code, right? That's usually the first, like the direction, because whatever I'm building out, I eventually want to automate it. That way I can have, consistent control and uniformity throughout the actual environment itself. The next thing I do is based on, especially when it comes to security and compliance, I try to keep consistent tool sets, or try to recommend keeping consistent tool sets to our clients. So it's okay to introduce new tooling and new technologies, but, say that for major sprints, the AWS and other cloud service providers, they call it evolving the architecture. And that's, during those DevSecOps sessions where, you have everybody together discussing, what the requirements are to maintain compliance, security, keep the business running, those type of things. That's a good time to explore new technologies that may help things out. And then keeping a consistent approach to monitoring and enforcing compliance throughout the different workloads. So based on the tooling that's being used, the next step that I'll do is explore just the default limitation that the tooling has in place. For example, like when we were taking a look at config and inspector last time, we took a look at a couple of the templated rules, but there are things like, maybe I don't want to enforce this across the entire environment. Maybe I want to enforce this on a couple like critical buckets, or maybe, I don't want to include like every single virtual machine in this review. So I try to push the limits for what can be done by default, and I see if I have the capability to customize it to whatever my particular needs or the organization's particular needs are at the time. And at that point, it's like, usually building it out a little bit more, introducing SNS, introducing Lambda is a more convenient, consistent approach to kind of go down. But it really depends on the actual workload and what the environment looks like. All right, cool. Got time for, I know we're running a little bit over, so appreciate everybody hanging out. Let's see here, got a couple more questions. So the other ones talks about, how we spend a lot of time actually creating the roles. And why do these services just not auto-configure? So AWS, their methodology is really they want to practice, least privilege. They don't just tell people to practice least privilege, but their services are implemented with least privilege. Not everybody is going to do automatic remediation. Some people want to get the list of things to do, and then they want to click in manually and remediate each one. So if you're going through and actually manually remediating each one, going through the findings and then reevaluating the rule sets, then having a role with the permissions to do more than that is really not necessary. So that's kind of like their thought process, limit access as much as they can. And another question I had here was any other ways to tackle automation? So it's all balance, I feel. We could go through and we could create a rule here for every single PCI control or SOC 2 control that exists. But then there's other, technologies that exist out there. What I recommend doing is, if people are selling you the world, saying that this particular technology could do all of these things, try to evaluate it or even bring us in. We've been known to do a bunch of like cook-offs or bake-offs or whatever you want to call them. And because we have a thorough understanding of how this technology works. One thing we want to prevent is, hey, are these guys selling you something that you could just turn on by default and have the full capability, and they're just putting it into another GUI, right? Or is this organization really customizing these things to do exactly what it says, and it is going to take you like 6 months with your current resources to actually build out a similar tool set, right? So it's all about understanding, what the organization's, I guess, like tolerances for, building the stuff out from scratch, understanding what exists in the world, and really complementing, your information security program and the direction you want to go. Certain clients, they're big tool shops. They love to play with a bunch of different technologies, and I love them because I get to experience a bunch of these different technologies and see how they work, how they don't work, and really dig under the hood. A lot of other shops, they're homegrown, custom baked, everything from scratch, right? The one thing I would recommend though, so even though this time we've worked with CloudFormation templates, as we're moving towards that infrastructure as code, you could use CloudFormation, but say you don't want to use AWS anymore and you want to explore Azure, or you want to mix up, the cloud service providers that are being leveraged, and you want to try out Google Cloud. CloudFormation is great. It also sets the baseline for Terraform. So kind of going between the two, sort of like how they interact with one another. A lot of like the terminology and the scripting is the same, so it's easy to port it over, but always keep that in the back of your mind. Are you locking yourself into an environment? If I do want to do something in like 10, 15 years, because how often are you guys migrating infrastructure? Apart from everybody having their own colos and maybe expanding or shutting down colos, it was a long time before, there was the opportunity that presented itself where it's like really, the cloud was this really equivalent solution that was cost effective, and a lot of things you used to have to manage no longer need to manage anymore, and have really that shared responsibility model. So really take this opportunity to not appreciate, but maybe do things that you wanted to do before from scratch and implement those excellent processes, introduce that automation, really work on hardening, your CI/CD pipeline, removing people away from the data. Because again, we find that, people aren't intentionally making mistakes. It's just that they're, during architecture, they're just maybe forgetting to ask the question and forgetting to, even get to the point where you need to make a decision. That's my little rant. Let's see here. I think that's all the questions. Oh, you're welcome. All the questions I have. I don't know if anybody from my team's still on the call. Matt, are you still there? Did you want to speak up before we end the webinar?
Yes, still here. No, nothing to add. I think you did a great job, and the questions were all covered. I want to thank the audience for all of their involvement.
Perfect. Thank you, everybody. Again, there's our website for all the webinar content, my Twitter, which I don't think has been updated for a while, but I promise we'll start putting stuff out there, and we'll also be standing up a cloud blog with all this information and different ways for you to reach out to us. But yeah, really appreciate everybody's time and coming to hang out, and we'll see you for part 3, where we're really going to evolve these processes, move towards an infrastructure as code, and really enforce compliance, and show you the different ways to either do it as code or explore things like boundary permissions, and allow your developers to really push the boundaries of what they can do, but still maintain compliance within the environments. One other thing I'll be excited that we're going to cover is explore tools like organizations that allow us to have predefined policy sets for things like, hey, this is a PCI environment, this is a SOC 2 environment. So not only does it allow you to regain control from all those AWS test accounts and stuff like that that may be floating around, but allows you to granularly kind of put them in a bucket to ensure that you have the same rule sets that are applied around them for your particular compliance and security needs. So looking forward to part 3 here in the next week or so. Have a good day. Bye.